Good morning, everyone. Welcome to our final press conference here at the EGU2018 General Assembly. Thank you all for coming. I'll just remind you one more time that I will introduce our speakers, then they will each of them give their talks in a row, and at the end we'll open the room for questions from journalists here in the room. And we are showing this online, and those watching remotely can ask questions via the chat feature just below the stream. And there are a couple of press releases related to this press conference, which you can access at media.egu.eu/documents if you haven't received our press packs. I'll now introduce our speakers. We have Andreas Schäfer, who is a PhD student at the Karlsruhe Institute of Technology in Germany. Michalis Vostokas, sorry, I'm mispronouncing it, who is a researcher with the Joint European Research Center in Italy. And finally, we have Marco Ansidai, who is a researcher at the INGV, the National Institute of Geophysics and Volcanology in Italy. And I'll hand over to our speakers now. Thank you.
Thank you. So when we take a look at, wait a second, you have to start here. When we take a look at the development of tourism in the world, we can see that especially some of the, let's call them from a European perspective, more exotic locations are growing regarding the tourist arrivals of the last years twice as fast as the world average. We can maybe ask the question, are those locations at risk from natural disasters? And we have seen in the year 2004 that some of them actually are. In the big Indian Ocean tsunami, more than 220,000 people have died, and of those were more than 2,000 European tourists. In addition, we have seen that in several of the affected tourist destinations, many hotels, sometimes complete proportions of the complete tourism industry had to close down in the months and years after. Because beaches are vulnerable entities. When a beach is affected by a tsunami wave can roll in and leave a lot of deposits like debris or sand from offshore and leaving the environment very damaged. Or it can completely remove parts of the beach through erosion. Or if the earthquake is near the coastline, the beach can no longer be there because it was uplifted or subsided by several meters and it's either now on a mountain or under the sea. So we asked the question, can we quantify potential tsunami losses to tourism industries along beaches? For that, we compiled a global tourism and destination database in conjunction with beaches. So we have more than 20,000 beaches all around the globe. In the database, almost 1 million hotels to assess within it, and more than 10,000 potential tourist destinations, all on a subnational level, and their gross domestic product associated to them. The potential losses which can be associated to a beach impact on such a beach can, of the tsunami impact on such a beach, we have derived from at least little empirical data we have from the last years, like we observed it in Thailand or other places around the world of the last decades. And what we did with the beaches, we simulated more than 10,000 tsunamis all around the world. We only considered the very largest ones, so this magnitude larger than 8, because smaller earthquakes are normally if they cause a tsunami, rather small. And we calculated the coastal amplitudes of wave heights and any coastline in that case. And we are taking a look at the potential of earthquakes and tsunamis all around the world, and we compile them for a time period of 500 years. We see on a world map that especially locations we more or less know are prone to tsunami effects like Chile, Central America, or Indonesia and Japan are coming up in these return periods. And we are taking an even longer look into a future. We also see that regions in the Caribbean or the Mediterranean are also affected by tsunamis, even though they are very, very rare. So we sent all these tsunamis on a very, very long time period to all the different tourist destinations, and we found that about $250 million of loss can be associated to the tourism industry through tsunami effects. And about every 10 years, we can also expect a $1 billion event affecting these the businesses. And with the impact patterns all around the world, we see two distinct patterns. We have locations on one side which receive tsunami waves fairly frequent every few years, but only with low to moderate wave heights like Hawaii, which is apart from a few thousand kilometers away between the big sources, but we have simply many, many regions where the tsunamis can come from and affect them. On the other side, we have places like the Eastern Mediterranean or Thailand, which is affected very, very rarely, but if it happens, it can have a very, very big impact. So when we're taking a look at the most affected regions, we have Hawaii as a number one because of all the potential tsunamis that come around from the Pacific Ring of Fire. We have also locations like Phuket, as we have seen in the year 2004, but also Bali, Chile, but also Western Turkey is coming up with infrequent but potential tsunamis coming from in the Mediterranean regions. In summary, we compiled the first global loss index for the tourism industry in regards of beaches. And in that way, we were able to identify potential business losses through tsunamis. And among the most prominent destinations, we find Hawaii, Bali, or even Turkey. And we hope with these results to raise awareness among tourists to be safer in the future by knowing what could potentially happen, but they don't need to be afraid. Thank you.
So, hello. I'm going to present also results from global flooding risk projections that we are doing in the Joint Research Center of the European Commission. So the reason to do this analysis is that, as we all know, the sea levels have been rising, and this we can see from measurements in the top left panel. While all our climate models, they are saying that this rise, which has been happening in accelerated rate, is going to continue to, and also it's going to accelerate further. At the same time, at the coastal zone, we have a lot of people living, we have a lot of critical infrastructure, high-value assets, and at the same time, all the projections show that the population is going to keep rising. So we have this coupling of the challenges from the physical domain, sea levels rising, at the same time coupled with socioeconomic development and increased presence of viable assets and people near the coast. So what we do at the Joint Research Center is that we try to combine a set of tools which are either on the oceanographic part or the socioeconomic. So as you see here, we consider different models that we simulate how the waves will change the future, the tides will change the future, the storm surge will change the future. We do flooding simulations in large scales. We combine this with exposure layers. So we have population maps, GDP maps. We have also projections, gridded projections of how these things will evolve in the future. And then this we put together in an impact model and calculate future losses. There is a lot of recent studies now. There are a lot of recent studies that show that the storms, the coastal storms, they will increase in the future, and this is what also our findings show. That, for example, a storm that now we consider the storm of the century. Let's say if we take this area which is around the tropics, we project that it will happen almost every year by 2050. And by the end of the century, this is going to be almost all over the world, and this is because the sea levels are rising. If we translate this in risks, you see here the expected annual damage aggregated for different continents. The different colors, so different scenarios of socioeconomic projections. So, of course, there is a lot of uncertainty because we don't know what the greenhouse emissions will be. We don't know what how accurate our climate models are. Different climate models, they give different projections. We don't know what will be the socioeconomic development because this depends on politics and other things. But what we see is that we have an increase of several orders of magnitude. So if we try to put it now in terms of what will be the relative change in the expected annual damage, this we see on the left side. And each group of bars is a different socioeconomic development scenario. And you see that, for example, in all cases, the green bar, which is Oceania, is projected to experience the biggest increase in losses, followed by Africa. And here we have like 45 times increase in the expected annual damage. If we see the number of people affected, the ranking of the continent changes a bit. Africa becomes more important. Second comes the blue bar, which is South America, and then Oceania. But for example, if we take this socioeconomic scenario, which is called fossil fuel-based development, North America is projected to experience the biggest rise in the number of people affected. These are all values for the end of the century. Now, what is important is that we know that the temperature is rising, and for that there is no doubt. The right figure was in the inauguration of the London Olympics, and it shows us, as these lines deviate from the center, it shows us how we reach the 1.5 degree warming. So the model showed that around 2030 we will arrive in the 1.5 degree warming. And we know that this is pure physics. The ocean absorbs 90% of the increase in energy that's coming through the atmosphere because the water absorbs more energy than the Earth. We know from geological records that many, many years ago, the sea levels, when we had this kind of warming, 2 degrees above the pre-industrial rates, we know that the sea levels were 6 to 10 meters higher. And we also know that the water expands when the temperature is increasing, and it expands faster as the temperature is increasing further. So this means that, okay, this sea level rise is going to happen even if one can argue if it relates to human activity or natural activity or whatever. What is important also is that we have many natural hazards. We have the climate that is changing. We'll have different impacts. The spatial patterns will change. But there is a unique thing about the coastal floods is that we have sea level rise with like a magnification factor. And for example, we see this in our results. For example, at this stage now, in the present day, the river floods, they are 0.4% of Europe's GDP, and they are projecting the future to reach 0.1% of the GDP. Coastal floods for the moment is 0.1% of GDP. They are 4 times less significant than river floods. But according to our projections, coastal floods are projected to reach 0.29 to 0.86 of the GDP. So they are going to become 3 to 8 times more important than river floods. And we have also other studies that show that coastal floods, they become among the most important natural hazards. This means that we have to adapt, and there are solutions. For example, the Netherlands, they live under the mean sea level for decades now. But implementation in global scale can be challenging. For example, imagine that if you have a small island in the middle of the Pacific, it's not easy to find the material to build a seawall or something, or a dune or a dike. For example, they keep some islands they're building with corals, but corals they protect from waves, so there are different challenges. It also has to do with costs. So, for example, a very simple calculation trying to see how much the Netherlands are spending for the coastline in terms of GDP per year, you get a percentage. It's a very rough estimate. It's 0.23% of GDP. But if Jamaica had to do the same, it would be 5% of GDP. And this is even if it would be technically feasible, it's economically a challenge. And that was my talk. Thank you very much.
Okay, hi everybody. So what I'll speak today is some results, some preliminary results arising from the CivMed Cost project, which is funded by European Union Humanitarian and Civil Protection. And the goal of the project is to try to identify the coastal zones of the Mediterranean, which are more prone to sea level rise and tsunamis and floods, because it's a problem with the local population living along the shores. So as already my colleagues described in their presentations, that sea level is rising at faster rates than in the previous centuries, and is accelerating in recent years with the rise in the global temperature. So So we expect that mean sea level will rise more than 75 centimeters by the end of the century, but different projections provide even more values, higher values. So this is among the most serious impacts of climate change that we have to face in the next year. So, and we have to take into account that sea level rise can be locally higher than these predictions because the intervening of land subsidence, because it must be taken into account for coastal zones we are undergoing to land subsidence, like Venice, for example. And land subsidence will amplify the effects of sea level rise, of marine flooding, and the loss of land. And then the latter will be subtracted to human activities, and so with social and economical impact on local population. So, and even in addition, in a sea level rise environment, the tsunamis and storm will be amplified. The effect of tsunami storm will be amplified. So this is a map of the Mediterranean. In red shown the coastal plains of the Mediterranean, which are located at within 2 meters above sea level. So low elevated coastal zone, or just we call coastal plains. And these are the areas which are most prone to sea level rise and tsunamis and storms. We have identified 163 coastal plains, and they have a surface, the amount of surface is about 5.5 million of soccer fields, just to have to give you an idea of the area that is prone to sea level rise. So the plot shows the local sea level, so the relative sea level rise projection for each one of the coastlines of these coastal plains. And values are very different because of the intervening coastal uplift, for example, tectonic uplift or coastal subsidence. In Venice and Lipari Island, here we have among the largest values of land subsidence. And in the Mediterranean, like also in the Calastra plain in Greece. So these regions will be more affected by sea level rise. To account for land subsidence, we use GPS data, remote sensing data, and we analyze sea level data from tide gauge networks. And for Northern Africa, where we have a lack of instrumental networks, we may use the geological indicators like the 5E marine terraces of 125,000 years ago, when sea level was about 7 meters higher than today. And the temperature, the global temperature, were higher than today, were about 2 degrees. So in the Mediterranean, there are tsunamis, as we are called in the other presentations, and tsunamis strike most part of the coastal Mediterranean, mainly in the eastern part of the Mediterranean. So you may see this dotted blue line, which represent the probability of the occurrence of tsunamis for the next 50 years. So where dark colors correspond to higher probabilities and light colors correspond to minor probabilities. So North Africa, Eastern Mediterranean, Southern Italy and Greece are the most exposed to tsunami occurrence during the next 50 years. And along this coast also exist many UNESCO archaeological sites, or UNESCO sites in general, not only archaeological. And they may suffer from tsunamis, of course, and storms, like, for example, the Venice Lagoon or the southwestern Turkey, which is subsiding, and also the island of Lipari is subsiding. We have a Roman Harbor here, which is about 12 meters under sea level presently, while the coasts are retreating due to erosion and coastal retreat, of course. So this is map of the expected land flooding for the Venice Lagoon by 2050 at left and 2100 at right, so the end of the century. And this map has been realized by combining the vertical land movements from GPS data and from the climatic scenarios from IPCC calibrated for the Mediterranean. And with a mean land subsidy of about 3.2 millimeters per year, most of the coast will be flooded today, so we have it's a real problem. And in case of the maximum land flooding at the worst climatic scenarios, we will have about 1.3 meters of sea level rise. So the mean sea level will be 1.3 meters higher than today by the end of the century. Thank you. I ask you to stay tuned with SafeNet Cost results and through the website and social media like Twitter and Facebook. Thank you.
Thank you very much for your presentations. We'll now open the floor for questions. Are there any questions from here in the room or from the web chat?
Andy Coghlan, New Scientist. Andreas, can you tell us or give a kind of a simple explanation of what data you use to actually work out your, which places would be most at risk of tsunami damage, which beaches? What sort of data did you put in to get that?
Well, we have more or less two kind of data types. So on the first part, we had, of course, to calculate how likely it is that an earthquake wave will occur there. And that is based on my last years of PhD work, calculating tsunami probabilities all around the globe. For that, using earthquake statistics, tectonic modeling, so the usual seismological tools to calculate hazard all around the world. On the other side, to calculate the exposure, we have our large database on tourism activities. So we had the hotels, we had beaches, we had how much revenue in the different regions are generated, and also a population correlation with that. And all of this combined provided us the losses together with empirical loss information from the last big tsunamis.
Thanks for the presentation. Andreas, did you identify any newly developing beach areas that are at higher risks than others, or see any sort of interesting patterns that were unexpected? And then related, does your work in some way, can it help communities and relief agencies even perhaps prepare for risks? Is there a good basis for that?
It can definitely help to prepare, because now we identified which regions are most vulnerable. So when you know where a specific risk can occur, you can then start to locate mitigation measures. And this could already start at least placing signs for which evacuation route you should put there, or at least inform your tourists, hey, we have a probability for tsunamis, but if you're safe, follow this route and everything's fine. And so, sorry, what was the first question?
If you identified any newly developing beach areas, you started talking about the growth in tourism, and I was trying to picture where, which areas might be, for me, unexpected.
So basically, almost all coastal tourist destinations have the potential with tsunamis. A little bit surprising was that especially the Eastern Mediterranean is having such a potential for that, even though it is very rare. And also a bit surprising was that actually like a place like Hawaii is coming up with high losses, but it is simply because there are so many sources all around, even though they are far away, that they can affect it. And the high loss that's coming out of it is simply because a rich country with a lot of buildings, a lot of exposure, a lot of beach tourism activity all around the coast, and this all combined leads to high losses. While in other places where you maybe not have so many values, but where the tourism industry itself is important, may become even more important in the future. So think about small islands like Tonga, or around the Coral Sea, Vanuatu, and so on, they have also frequent tsunamis and a developing tourism industry. So they should early adopters of a resilient mitigation of all these risks. Yeah.
Hi, Marlo Hood with Agence France Presse. Question for Andreas. Just actually following up on the very first question on the data that you factored into these measurements. So on the one side, just the risk of a tsunami happening, and then the sort of dollar value of the tourism. How did you weight those things? Because I look at the list and it just seems like the most, tourist-intensive beach areas, a list in the world. And then sort of a subsidiary question, is it possible from your data to calculate, for example, just the pure risk of a tsunami happening? I mean, if someone is going to Waikiki Beach for 7 days, they have a 1 in how many chance of experiencing a tsunami, for example?
Yeah. So calculating the individual risk is, of course, absolutely no problem in that case. I mean, we know how often, or we have like an average of what is potentially possible on tsunamis all around the world, and aggregating this. So the general probability of a tsunami to observe at a location was at the very first place. And then we put the information on how the risk for the tourism could look like. And that, of course, locations which are known for their tourism at the moment, like Bali, Phuket, or Hawaii, are currently on top of the list, is simply because the tourism industry is well developed there. So there is a lot that could be damaged in such an event. Yeah.
And for the hypothetical that I gave, do you have even a rough idea of the chances if you're spending, say, 7 consecutive days on Waikiki? What are your chances of seeing a tsunami?
To be honest, I don't remember the exact name for Waikiki, but one number I have still in mind. So if you're spending a day at the coast of Mexico, you have a probability of 1 in 600,000. 1 in 60,000. In Crete, you have 1 in 600,000. So 1 in 60,000 days.
Thank you. Are there any additional questions from here in the room or the chat?
I did have a question for Michalis as well. I wondered if you could elaborate a little bit on what you said. I'm just looking at my notes. You said that a storm of the century today, so something that would occur once every 100 years, by mid-century will be happening somewhere in the world once every year?
Yes.
Yes. That's sort of a startling number. And I just want to make sure if you could elaborate a little bit on what you mean by a storm of the century. And
well, basically, this is something that also previous studies have found. The step forward that we did is that instead of only considering sea level rise, we also consider the spatial changes of the contributions from waves, storm surges, and tides all together. The thing is that imagine that, for example, if you go to the Mediterranean Sea, an extreme event is like, I don't know, maybe a storm surge of 1 meter is extreme. So in these macrotidal areas, where you have no tidal variations, episodic increase of 1 meter is a lot. So imagine what happens if you have, let's say, 30 centimeters of sea level rise. It's already 30% of the very rarest event. So this means that if an event that will increase the sea level for 1 meter, it happens every century. An event that decreases the sea level for 70 centimeters happens every 10 years. So I just make a very simple example. That's why with 30 centimeter sea level rise, you will have the event of the century now, you will have it much more frequently in the future. So basically we have this rise. The more dramatic rise takes place in the areas where they are relatively confined, so we don't have these high waves of the Atlantic, for example, that you can have waves of 15 meters when you have extreme conditions, where you don't have high tides, because tides can be like 9 meters if you go to Cornwall or the northwest of France. And so where you don't have these high extremes, the high variations, sea level rise becomes very important. and increases a lot the frequency of the extreme events.
Do we have any more questions? If not, we'll finish here. You are welcome to approach our speakers and book one of the 4 interview rooms we have available on the site. Okay, it looks like Marlo has another question.
Just a question about the availability of the PowerPoints. Are those online somewhere, or could they be?
Yes, yes. Yeah.
Is that all right? Okay. Thank you.
Well, some data are not yet published, so I would prefer not to distribute this version anyway of the.
You can send it to
It's
me,
possible.
whatever version you think it's
Yeah, I
suitable
will
online,
provide
and
you-
I'll
yes,
upload it.
Yeah, of course. Thank you.
Okay, so then let's finish here as our last press conference. Thank you all very much for coming. Thank you for being here. We are finished here at the press center, but there are a number of activities happening elsewhere, such as a debate today on natural versus anthropogenic threats to life on Earth. And tomorrow we have a session on scientific research in a changing European Union, so that might interest some of you. If not, I'll see you next year, 7th, 12th of April, 2019, here in Vienna. Thank you. Thank you very much for your talks, and thanks for coming. Bye.
Thank you.
Thank you.
Thank you.